All right, so we're gonna officially start these problems in a few minutes, but setting up your axes for this one, you might want to put a little break here which says, I know that this scale is off, but now I'm going to start at 50 and I'm going to count by 1 each time. And then down here you can just have 1, 2, 3, 4, 5, like so. For this one, I believe we are going to want to count by maybe tens or so. So if this is 0, then we would have, maybe we can count by 5s. Now let's just count by 10s. So you've got 10, good morning, 20, 30, 40, 50, 60, 70, 80, 90, and 100. And then you can keep going if you need to. And then on this side we've got 10, 20, etc. Okay, so I'm going to encourage you to look back at your notes, and if you don't have your paper notes, to look back at the notes online. Remember the day that we became experts was Unit 3, Day 2, and there are some good example problems in those online notes. Also, you have your own packet. So I want you to discuss with each other about how you plan on graphing these. There's more than one way to do it, and I'm interested to see all the ways you guys decide to graph these. Make sure you read the story too, to see what it is you're graphing. Okay. So first is a method that I saw a lot of, which was making a table of values. All right, so let's compare your work to Kai's work here. A lot of you chose either 0, 1, and 2 in your table of values, or you chose 1, 2, and 3. And when you chose those numbers, you should have substituted them into the equation to find your y values. And so some of you had 50, 53, and 56. Some of you had the 0.359 on here. All right, and that should have given you your line right there. Some of you chose different numbers. So let's look at Kelly's. Kelly decided that she might study for 10 or 12 or 16 minutes. Totally fine. And so she got different y values for those. And even though this line looks different from Kai's line, that's only because Kelly used a different scale. So she counted by 2s on her x and she counted by 10s on her y. But this actually is the same line that Kai got. And then lastly, some of you used the slope and the y-intercept. So if you compare your work to Kevin's, you might find that you started at 50 and you did a slope that was up 3 and over 1. And those are all good ways of graphing this. Raise your hand if you use a table of values like Kai and Kelly used. Anybody use a table of values? Eamon did? Anybody else? I saw some more table of values out there. Emma, you did? No? Okay. Raise your hand if you did slope and y-intercept like Kevin did. Okay, see a few of you did that. All right, excellent. Okay, so let's actually read through the problem on that one just to make sure that we can make some sense of it, and then we're going to go to the next one. Okay, so for this one, we said your math teacher has a theory: if you don't study, you'll still earn 50%. That's why we mark 50% right here. And you'll earn 3% more for every minute that you study. The grade y, so make sure that on your y-axis you have marked that this is your grade. The grade y can be expressed in terms of the number of minutes you study. Make sure you have that on your x-axis, okay? And with the equation y equals 3x plus 50. So I'm going to put some of the points that I saw on those 3 papers there. So unfortunately, my graph, the way I drew it, it doesn't go as high as the grade I want. I want a grade that's like bigger than 65. How many minutes should I study if I want an A? You guys want to give me a guess and we'll try it out?
Try 10.
Try 10, okay. So if I studied 10 minutes, it would be 3 times 10 plus 50. So I get an 80. Am I at an A yet?
No.
No, but I'm getting closer, right? What else could we try?
13.
Did you say 15?
13.
Oh, 13, okay. So 3 times 13 plus 50, 39 plus 50, 89. I'm super close, right? So how many minutes do you think I should study if I want an A?
15.
All right, let's try 15 minutes. So 45 plus 50, that gives me a 95. All right, so maybe I should be studying 15 minutes to see if I can get an A on my quiz. Excellent. So in this case, maybe I should have given you a bigger graph. Amara was pointing that out to me for the second one. He wanted a bigger graph, right? Yeah. Does somebody want to read the second one to us? Thanks, Dion. Nice and loud, okay?
Read the
Second problem.
word.
Yes, please.
A Drummond apartment hopes to earn $1,000 from the ball play. Student tickets cost $5 and adult tickets cost $10. If they sell X student tickets and Y adult tickets, the equation will be 5X plus 10Y equals 1,000 minus all possible combinations of tickets to achieve their goal. Graph the line and label the axis.
Excellent. So I'm going to start with labeling the axes because it tells me X student tickets. So student tickets are here. And Y adult tickets. Okay. Looking at this problem, can I graph this with the slope and y-intercept? Does this problem, is it set up with the y equals mx plus b like the other problem?
No.
Yeah, it looks different, right? I could actually try to get that y by itself. That's not something we've practiced this year, but some of you might remember how to do it from a previous year. So that's a possibility. But because it's set up differently, which of the three methods did you use to graph this? 1, 2, or 3? Maybe I'm not being clear because numbers aren't helpful. Did we graph this with the slope and the y-intercept, or did we find both the x-intercept and the y-intercept?
Both.
We did find both of them. And I noticed this on several of your papers, that you substituted 0 for the x, and then you substituted 0 for the y. And this was my equation, so I'm going to start by substituting 0 for the x. Oops, sorry, that should be 10x. So 5 times 0 will make 0, and I have 10x equals 1,000. And what do I do next? Divide it, good. Okay, so I get x equals 100. Did anybody else get an x-intercept of 100?
100.
All right, you guys are making me doubt myself. Raise your hand if you also got x equals 100. A couple of you got it? Okay, so let me just review what I did. To find the, oh, I understand why you're doubting me, because it's not x, is it? What is it?
Y.
It's y, okay. See, I knew I was doing something wrong, or I would have had you with me. Okay, it was 5x plus 10y equals 1,000, and then we put the 10y equals 1,000 and divided by 10. So you guys are right. It is y equals 100. Wish I had another color. I think I do. Okay, so on the y-axis, I'm marking 100. And then I think I'll use this space over here just so I don't have to zoom out. So then I'm going to do 5x plus 10 times 0 equals 1,000. And then this makes 0. And I get 5x equals 1,000. And I divide it. And we get x equals what? It was bigger this time, right?
Yeah.
How many? Joseph, I think you got it, right? Did you get it? I was asking Joseph if he got an answer for this one. It was 20? 200. Very good. 200. All right, so I got 150, 160, 170, 180. I'm just going to have to extend a little bit. 190, 200. Okay, and I'll put a dot there. All right, so look, this represents all the different possibilities of adult tickets and student tickets. We could sell just 100 adult tickets and no student tickets, but that would be weird to have no students going to the play. You could sell 200 student tickets and no adult tickets, but that would also be weird because people's parents want to go see them. So the true answer is probably somewhere in the middle. Like maybe it's this point, which is 100 student tickets and 40 adult tickets. Or maybe it's this point right here, 20 student tickets and 90 adult tickets. Okay, so any of the points on this line could be the combination of adult tickets and student tickets. Any questions? Okay, let me stop that recording.